Welcome to this session on Policy as Code for Network as Code. I'm Nico Vibert. I'm a staff solutions engineer at HashiCorp. So the session will start with a brief intro about me and why I'm passionate about network automation in general. We walk through the different steps in what I see network engineers take to accelerate their network automation journey. And we walk through why you might use Policy as Code for Network as Code. But we'll delve into a demo after about 10 minutes. So just a brief intro, who am I? So I'm essentially a network engineer at heart. I started my career about 17 years ago now and spent the first 10 years as a, let's say, traditional network engineer. I worked for Cisco partners and then eventually for Cisco. And I did everything, support, implementation, architecture, design. Did my CCIE back in 2008, and then eventually moving to network virtualization. I joined VMware, worked on NSX for a few years, and then again I pivoted into DevOps and GitHub, and I got really amazed the first time I saw Terraform in action, and I'm really passionate about automation, and also because I think about the days when I was doing network implementation, and back then we had no means to automate. Right? There was no REST API on any of our Cisco devices, so it was just simply impossible. So if you wanted to do any kind of network automation, you had to go and SSH into a device and scrape the logs and try to interpret the output. It was a nightmare. And now we've really evolved, and we have many more options to automate our network. So let's talk about, I guess, the first step a network engineer usually takes in his or her journey. So very often, I see network engineers using Python and do some scripting for automation around the network. And I love Python. I've written thousands of lines of code of Python. I think it's fantastic. But it's often used in a tactical way to achieve a determined outcome, right? Which is, again, absolutely fine. But it's not necessarily full-blown automation, right? So the next step I see users take is to look at infrastructure as code. And what I see is many network engineers look at Ansible, maybe for your kind of traditional networking, your Cisco, your Arista, Juniper, and users using Terraform for your kind of cloud networking, right? So again, both options are absolutely fine. I think the landscape has changed a fair bit now in terms of Terraform support for network and security devices. If I look at the amount of providers, and you can see this on the Terraform registry, there are hundreds of providers now, thousands of providers available, but if you want to automate your network, you can use Terraform for AWS, GCP, Azure, of course, for cloud networking. You can also use it for your kind of traditional network, whether it's Cisco, Checkpoint, Palo Alto, Arista, and also for kind of your modern kind of cloud networking requirements like Aviatrix, for example. So again, lots of options to now for your networking by using infrastructure as code, Ansible, or Terraform. Now, it gets really exciting, and what I see customers are moving towards is then integrating with a CI/CD pipeline, whether it's Jenkins or Circuit CI, or simply with their version control system. And you really get the benefits of coding, tracking changes, rollback, working as a team through, pull requests, etc. And we'll see an example later in the demo. It starts getting really exciting. Now, you still have a lot of humans involved in the process, right? In many of these situations, whether using infrastructure as code, you still typically have somebody writing the actual code. So I guess you have to eliminate as much as possible places where a human can make mistake, because when you read about network automation, you see the headlines about how it's going to remove network outages or minimize network outages, and it's I think it's true, but I think it's still partially true, right? It's still just because you're using infrastructure as code doesn't mean that you will eliminate outage straight away, because you still have humans involved. So one way to address this is to start using a network source of truth. So it could be Netbox, where you typically can store your desired networking configuration and pull information from Netbox into your Ansible or Terraform. Or you could use something like Consul Terraform Sync, where again, you use Consul as a service registry, where you define your networking configuration and automatically will trigger Terraform and execute Terraform on your behalf. And brilliant. What's still missing from all of this is the ability to go and leverage some of the wisdom we've required around networking for the past 10, 15, 20 years. Right. And I talk about wisdom is all the best practices, all the things to do or not to do. How to automate, but with some kind of, care and prudence. And a good word to describe this is policy. One definition of policy, as you can see here, is around prudence and wisdom. And that's really what we want to apply to our automation to ensure that we have some kind of guardrails and governance around how we deploy our networking infrastructure. And within HashiCorp, we have a framework called Sentinel. That's the way we do policy as code. And you also have platforms like OPA that kind of achieve similar outcome. In the demo, I'll be looking, of course, at Sentinel. So again, this is a journey for many of our customers to go from a tactical approach to full-blown automation with some guardrails. So let's look at policy as code with a number of network examples. So imagine you're a network engineer, a cloud network engineer using AWS. You're creating VPCs and security groups and VPNs. Let's look at a few examples of good code versus not so good code. One example is you're creating on a VPC on the left-hand side here, and you've got a tag. You remember to do the tag. We use tags in the cloud for automation, for governance, costing. Metadata is brilliant for this. On the right-hand side, you see a resource that is missing the code. Again, it's not the end of the world, but what you want to do is flag if your Terraform configuration is missing a tag. Right? You want to just highlight that the configuration doesn't meet best practices. Similarly, imagine you're building a VPN. Right? Ideally, what you want your VPN is to use the most secure algorithms and ciphers. So on the left-hand side, I'm using Diffie-Hellman Group 19, which is, say, more secure than Diffie-Hellman Group 2, which you can see on the right-hand side. And again, it's not something that is easy to teach, your CI/CD pipeline. So you have to be able to take this kind of best practices and policy. And what we're going to do is write them as code, and they will inspect your Terraform configuration and will highlight that this, for example, is not a recommended protocol. And finally, the last example is around the security group. So again, imagine you're building a EC2 instance, you're opening, but you only want to open access to some limited resources. So ideally, yes, you specify the VPC, it could be a whole CID block or a specific subnet, or another security group. Now, what you don't want to do in the vast majority of cases is open up to the whole of the internet. Right? So we need to be able to pick up on some of these security gaps and prevent the Terraform to be executed. And that's how we're going to use policy as code in the demo, is to look at our Terraform configuration and using policy as code, tell whether the network would meet best practices or meet our governance and security policies. So we use something called Sentinel. Sentinel is again works with all the HashiCorp products, and it's really a way to automate provisioning and to put some guardrails around your automation. It's typically done between your Terraform plan and your Terraform apply. That's kind of where it's executed. And we write Sentinel policy. We take a policy, again, it could be a security policy, a compliance policy, a best practice policy, and we write them as code. This is just an example. On the right-hand side, we'll look at a few more examples in the demo shortly. And the code will inspect your Terraform configuration and will tell you whether it passes or fails the policies. If it passes, great, Terraform will go ahead and do the change. If it fails, we have different enforcement levels. Now, if you fail the policy, you might want to just send a warning, right? Just it's a minor policy fail. And the second enforcement level is what we call soft mandatory, where the policy will fail, the Terraform will be stopped, but you can decide to override the Terraform, the Sentinel policy failure. You might have a good reason for it. And we'll see again in the demo shortly. And finally, we have something called hard mandatory, where Sentinel will pick up the policy fail and will decide to stop Terraform from being executed. Because again, it might be a serious security deficiency in your Terraform code. So let's go ahead and do a demo. We're going to use Terraform Cloud for this. And what you will see is we'll link our Terraform Cloud workspace to a GitHub repo and start using, we'll attach a Sentinel policy, and then we'll go and apply Terraform and try to deploy the networking configuration and see what happens. Right, so let's go and get started. So we're going to create a new workspace, and we're going to connect it to my GitHub. And we're going to use this one. And create the workspace. No, this is already. We'll call it HashiTalk. And let's create it. And that repo here is where I have stored all my networking as code configurations. So you can see I'm using AWS as a provider. And we're going to create a VPC. Going to create a number of security groups. And we're going to go and create a VPN. And using the example that we used before. So I've set up my workspace. I've put my passwords in here as all my variables, and I can go ahead and start a new plan. So I should talk, and it's going to use my Terraform configuration, which we've seen above, and start deploying the resources I've specified. So Terraform Cloud runs a Terraform plan, and it's going to go and create 6 resources: customer gateway, security groups, all the VPC, etc. As part of this, is doing a policy check. The policy check is here, and it passes. So what we've done is we've actually attached a number of Sentinel policies in here. You see, it's on a GitHub repo. I've attached it to my Terraform Cloud workspace, and I've got 3 policies. Another 3 policies that will essentially look whether I've got a tag on my resources. It will look whether I'm using the right Diffie-Hellman group for my VPN, and a policy that will look whether I've got a wide open security group. Right? And as you can see, they all have different enforcement levels. This one is advisory. So if I'm missing tags from my Terraform configuration, we'll just flag an advisory. And if you look here, you can see that my advisory failed. So what happened is I have some tags missing from a set of resources. And you see in the logs, so I've got VPN connection, it's missing a tag, and the customer gateway is missing a tag as well. So Terraform Cloud and Sentinel are telling me I failed that policy. I don't have a tag. But because the enforcement level was only advisory, it's okay. We can go ahead with the change. Okay. The plan and the resource will be created. We also have you can see the soft mandatory VPN has passed and the hard mandatory police has passed. Right. So why? Because I'm using so I'm not using 0.0.0/0, and I'm using Diffie-Hellman group 19 in here. Now it's going to take about 5 or 6 minutes to deploy. So we'll pause it just for a couple of minutes. Now I've got the Terraform apply. It's finished. It takes about 4 minutes. And I look at my AWS configuration. I've created a Diffie-Hellman group 19 on my VPN, and the run is completed. Now, what happens when I actually change my Terraform configuration? So, for example, we're going to go and change group 2. So now we're going to use a vulnerable cipher for our IPsec tunnel, and I expect that Sentinel will pick it up and detect that I'm using the wrong type of configuration. So when I commit to the main branch, what Terraform Cloud will automatically do is execute Terraform plan. You can see last commit was DE411C6. You can see it in here, and you can see the name of the commit message. So Terraform is reading a plan. It can see that planning to just change one resource from 19 to 2. And this time we have a different policy failure check. Right? We still have the problem with a missing tag, but we also have failed policy around the VPN. You can see some of the messages. So one of my policy detected and we can have a look at the policy here. The policy is actually, so it's written in a language called, it's a Sentinel language. And if you exclude also the description, it's just about 5 lines of code. So we essentially create a list of all the permitted DV-Hellman groups. We find all the resources in our Terraform plan of the type AWS VPN connection. And then we look for all the VPN that have a resource, an attribute for which the value is not 19, 20, or 21. And if we find a resource with an attribute that is of tunnel 1, phase 1 TH group numbers is not 19, 20, or 21, we will flag this as a violation. So it's literally 6 lines of code to be able to detect a misconfiguration in your Terraform configuration. Now, again, there might be a good reason for using a DH group 2. So you can actually override the decision. Right now, Terraform has said, it's there's a policy failure, but you can actually override. So you could say, it's okay. I am building a VPN to a legacy device, right? So it will go ahead, build the VPN. Terraform will carry on, and the configuration will be applied. Now, this time I'm just going to discard it, and we're going to do the final policy check. So going back to my configuration, what I'm going to do this time is I'm going to create a wide open security. Right? We're going to go back to number 19 here. This time in ingress, instead of 10.0.0.0/8, we're going to do a wide open security group. Okay. And again, Terraform will be, as you can see, executed. So as always, Terraform plan, looking at differences between current state and the configuration, the desired configuration, and it's going to tell me that only one object needs changing, and that the security group with ingress block is going to go from 10.0.0 to 0 slash to the default 0.0.0/0. Now, the difference here you can see is the policy check is hard failed. Right? Because we set our policy to be a hard mandatory, and our policy will again check whether the security rule is has a 0.0.0 as an ingress subnet, we will fail the Terraform execution. There's no way to override it. There's no way to carry on with Terraform, and the apply will not. So by doing this, we've stopped ourselves from executing a bad Terraform networking code. So hopefully you can start seeing the potential here, right, of using policy as code with network as code. You can take all your best practices, translate them as Sentinel policies, and apply to all your network automation code. And that gives you that kind of peace of mind that when automation is taking care of things, it's done in a safe and prudent manner. So I just wanted to, again, finish off by just recapping some of the key takeaways. Network automation is a journey. Again, absolutely fine if you start with some Python scripts, and you might want to use Ansible if you prefer that, or if you start looking at Terraform. There are lots of different providers for your network devices. but aspire to as much automation as possible, and to remove human roadblocks and ticketing systems as much as possible, right? Now, find a way to apply network automation, but by leveraging some policy as code, you can do it in a safe manner. Okay, that's the end of the session. Again, thanks for watching and have a great day.